Hi, welcome to all. Myself Usha from SA Engineering College, Assistant Professor, Department of Mathematics. Today we are going to see the lecture about chi-square test. So these are the following content we are going to see. First one about population and sample and notations used in population and sample, testing of hypothesis, parametric and non-parametric test, applications of parametric and non-parametric test, chi-square test, goodness of it, properties of chi-square test. Based on this we are going to see problems. So first we define what does mean by population and sample. So here population represents group of individual is called population. From this we will select a part of population is called a sample. So it is a subset of population. Next, comparison of population and sample. So who represents the population? That is, we are dealing with the subjects of particular study. Example, we collect samples of voters, dentists, college students and children, etc. These are all comes under population. Next, what? The parameter, that is the characteristics of population. Example, the characteristics of population are gender, age, income level and education level, etc. So based on this we select a sample, that is survey of the whole population represents the problem. Next we find the solution of this problem, that is use a sample for the who. From this we select the population, calculate a statistic from what. So these are the notations, important notations used for the population and sample. So population, it is called as the parameter, and for sample it is called as statistic. So these are the notations used for the population, that is for size we are having capital N, and for sample it is denoted as small n. And for mean of the population notation is mu, and for sample it is called as x bar, and standard deviation it is called as sigma, and for sample it is used as small s, and for proportion it is called as p, capital P, and for sample it is as small p. These are the important notations we are going to use in problems. And next one, testing of hypothesis. So first, what is meant by hypothesis? Hypothesis is a statement. So on the basis of sample information, we make certain decisions about the population. So first one, we set up null hypothesis, that is there is no significant difference between the observed value and expected value, and alternate hypothesis which is complementary to null hypothesis, and it is denoted by H1. And next one is critical region and level of significance. So critical region means the rejection region of the null hypothesis in the testing of hypothesis. This is called critical region. The rejection region of the null hypothesis is called critical region. Next one, level of significance. It is denoted by alpha, that is the probability of rejecting a null hypothesis is called the level of significance. Mostly it is in problems it is given. If it is not given, we assume alpha as 5% or 1%. Next one, these are the procedure for testing of hypothesis. So first one, we set up a null hypothesis H0. Next, we define alternate hypothesis H1. And next one, we choose the level of significance alpha equal to 5% or 1%. And fourth one, test statistic. By using the formula we are doing the calculation, so it is called as calculated value. Next one, table value which will be already defined. And next one, conclusion. If calculated value is greater than table value, we accept H0. If calculated value is greater than table value, we reject H0. These are the procedures for testing of hypothesis. Next one, parametric and non-parametric test. So first we define what is meant by parametric test. So parametric test means it has all the information about the population parameter. That is, the population parameters are size of the population, mean of the population, standard deviation, etc. And non-parametric test, it has no idea regarding the population parameter. Next, these are the applications of parametric and non-parametric test. So the purpose of application, comparison of two independent groups. We are applying t-test for independent samples, and for non-parametric test we are applying Wilcoxon ransom test, and test the difference between the paired observation. That is, for dependent variable dependent samples we are using t-test for paired samples, and Wilcoxon sign ransom test for non-parametric test. And for comparison of several observations, ANOVA used for parametric test, and Kruskal-Wallis test is used for non-parametric test, and test the association between two qualitative variables. So for this, for parametric test there is no test is found. So for non-parametric we have chi-square test. So these are the applications of parametric and non-parametric test. Next one we will discuss about chi-square test. So chi-square test is a very powerful test for testing the significance between theory and experiment was given by Professor Carl Pearson in 1990. So the main uses of chi-square test are goodness of fit, independence of attributes, and population of variance. So we are discuss about goodness of fit. So chi-square test, goodness of fit, it is defined as if the graph between observed value and expected value is fitted, one can see whether the values are close together or apart. So when observed values and expected values are closer together, the chi-square test value will be small. So decision must be not reject H0. So the main aim of goodness of fit is we have to not reject the H0, hence there is a good fit. The next one, the properties of chi-square test. These are the main properties. So first one, the mean of chi-square distribution corresponds to the number of degrees of freedom. And next one, the variance of chi-square distribution corresponds to double the number of degrees of freedom. And next one, the chi-square distribution curve approaches the normal distribution curve as the degree of freedom increases. When the degrees of freedom of chi-square test increases, it will approach to normal distribution. So degrees of freedom means the number of given observations, given samples minus 1 represents the degrees of freedom. Next one, these are the procedure we are going to apply. So first we set up H0, that is favor of the given problem, given statement, and H1 and favor of the given statement. And choose, if alpha is not given, we choose alpha as 5% or 1%. So test statistic, that is by using this calculation, that is this formula, we are finding the calculated value of chi-square. So chi-square formula is summation O minus E whole thing square by E. Here this O represents observed frequency and E represents average or mean, that is expected value. So E represented as summation of observed frequency divided by N. And fifth one is table value for chi-square. This can be found by using n minus 1 degrees of freedom. And next one is conclusion. That is conclusion by comparing the calculated value and table value. If the table value is greater than calculated value, we accept H0. If table value is less than calculated value, we reject H0. So now we will see the example. It is given the following data gives the number of aircraft accidents that occur during the various days of a week. find whether the accidents are uniformly distributed over the week. So the table value of chi-square is given in the problem itself. It is 12.592, and here the sum: days Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday, and number of accidents are on Sunday 14, Monday 16, Tuesday 8, Wednesday 12, Thursday 11, Friday 9 and Saturday 14. So here in this problem it is not dealing with any population parameters, that is population size, mean, standard deviation, etc. will not be given. That's why it is called non-parametric test. So by using goodness of fit, we are seeing. So solution: first we set up the null hypothesis H0. So it is given the accident are uniformly distributed over the week. So the given accidents are uniformly distributed, that is evenly distributed for the week. And H1, that is the alternate hypothesis, the accidents are not uniformly distributed over the week. Here the significance level alpha is not given, so we define alpha as 5%. So that's why we choose alpha as 5%. Next, we do the calculation, that is test statistic. So chi-square equal to summation of O minus E whole thing square by E. Here O represents the observed frequency. So the observed data are 14, 16, 8, 12, 11, 9 and 14. Therefore, we already know the formula: expected frequency E equal to summation O by N, that is observed values by number of frequency given. So E equal to 14 plus 16 plus 8 plus 12 plus 11 plus 9 plus 14 divided by 7. So that is equal to 84 by 7. We cancel, it will give 12. So our expected value is 12. Next. So based on the given observations, data, we are doing the calculation. So observed frequency 14, 16, 8, 12, 11, 9 and 14. And here the expected value we already find. So the expected frequency will be same for all the given observed values. So expected frequency will be 12, 12, 12, 12, 12 and 12. And using the formula O minus E whole thing square by E. So here 14 minus 12 whole thing square divided by E will give 0.33. Similarly, calculate 16 minus 12 whole thing square divided by 12. So it will give 1.333. And 8 minus 12 whole thing square divided by 12. So 1.333. Similarly, the remaining observations we are doing the calculation. So we are having 0, 0.083, 0.75, 0.333. Therefore, sum of this value, that is summation of O minus E whole thing squared by E, will be equal to 4.165. So this value is called as our calculated value, that is calculated chi-square is 4.165. So by calculated chi-square is 4.165. Next, table value, it is already given. So table value for V n minus 1 degrees of freedom, it will be 6 degrees of freedom. So our chi-square test will be 12.592. And conclusion, comparing calculated value and table value. So here calculated chi-square is 4.165 and table chi-square 12.592. So calculated chi-square is less than table chi-square. Therefore, we accept H0, that is the accidents are uniformly distributed over the week. So we are moving to the next problem. It is given 4 coins were tossed 160 times and the following results were obtained. So here we are tossing 4 coins. So 4 coins, we are getting a possibility of 4 tails and 4 heads. So here observation about number of heads. So number of heads are 0 head, 1 head, 2 head, 3 head and 4 head. The observed frequencies for 0 Hz 17, 1 Hz 52, 2 Hz 54, 3 Hz 31 and 4 Hz 6. So under the assumption that the coins are balanced, whether in this assumption we have to check the coins are balanced or not, find the expected frequency of getting 0, 1, 2, 3, 4 Hz and test the goodness of fit. We have to test the goodness of fit for the given problem, and the table chi-square is given, that is 9.488. So solution H naught, we are speaking about coins, so the coins are balanced. H1, the coins are not balanced. Here alpha is not given, so we choose alpha as 5%. Next, for calculation, so test statistic, chi-square will be equal to summation of O minus E whole thing square by E. Next, we have to find the expected frequency, because only the observed frequencies are given, we have to find the expected frequency. So we know that probability of getting head is 0.5, that is we assume P equal to 0.5, and probability of getting tail will be 0.5, that is Q equal to 0.5. Already we know that probability value will always be equal to 1, that is it has half failure and half success. So total probability will be 1. Here for tossing a coin, the outcomes are head and tail, and the possibility of getting head will be 1 by 2, that is 0.5, and the possibility of getting tail is 1 by 2, that is 0.5. So for this we are using binomial distribution to fit the goodness of fit. So we know that P of x equal to x binomial distribution, NCX P power x Q power n minus x, where x takes value 0, 1, 2, 3 and 4, because we are considering only 4 coins. So first one, P of 0 head, so that is equal to P of x equal to 0. In the place of x, we replace x as 0. We are getting 4C0, 0.5. Already known P value 0.5, Q value 0.5. So 0.5 whole thing square into 0.5, 4 minus 0, that is equal to 0.0625. Similarly, P of 1 head, that is equal to P of x equal to 1. So 4C1, 0.5 whole thing power 1 into 0.5 whole thing power 4 minus 1. 0.25, and P of 2 head, that is probability of 2 head, we have P of x equal to 2, that is equal to 4C2, 0.5 whole thing square into 0.5 whole thing power 4 minus 2, that is 0.375. And next, to find probability of 3 head, that is P of x equal to 3, we have 4C3, 0.5 whole thing cube into 0.5 whole thing power 4 minus 3. So it will take 0.25. Similarly, for P of probability of getting 4 head, we are having 0.0625. Next, the calculation. So number of heads, we are having 0 head, 1 head, 2 head, 3 head and 4 heads, and observed frequencies are 17, 52, 54, 31 and 6. And we have to find the expected frequency, that is expected frequency will be equal to, here the number of tosses will be 160 times they are tossing the 4 coins, so 160 into probability of x. Already we find the probability values for 0 head, 1 head, 2 head, 3 head and 4 head by using binomial distribution. So 160 into 0.0625 equal to 10. Similarly, we find for 1 head, 160 into 0.25, that is equal to 40, and 160 into 0.375 equal to 60, and 160 into 0.25 will be 40, 160 into 0.0625 is 10. So now calculation O minus E whole thing square by E, that is observed value minus expected value whole thing square divided by expected value. So observed value 17 minus 10 whole thing square by 10, we are getting 4.9. And 52 minus 40 whole thing square by 40, that is equal to 3.6. And 54 minus 60 by 60, that is equal to 0.6. And 31 minus 40 divided by 40, that is equal to 2.025, and 6 minus 10 whole thing square by 10, that is equal to 1.6. So the total of O minus E whole thing square by E will be 12.725. So this is our calculated value. So our calculated chi-square is 12.725. Next, the table value, it is already given. So here there are 5 samples. So 5 minus 1, we are having 4 degrees of freedom. So chi-square at 0.05 will be 9.488. And conclusion, comparing the calculated value and table value, calculated value is greater than table value, therefore H0 is rejected. That is, the coins are not balanced. So next we will see problems. So what is the mean of chi-square distribution with 12 degrees of freedom? So the options are 4, 12, 6 and 8. So already we discussed the properties of chi-square distribution. Mean of chi-square distribution will be equal to the number of degrees of freedom of the given chi-square distribution. Here the number of degrees of freedom is 12. Therefore the answer is 12. So answer is B. And next one, a bag contains 100 toys. It has 5 different colors of toys in it. So it contains 100 toys and there are 5 different colors in the bag. If all 5 colors of toys were equally likely to be put in a bag, what would be the expected number of toys of each color? So here the options will be 12, 11, 20 and 9. So already you know that expected frequency so number of toys will be 100 into, so there are 5 different colors, so it is a chance of taking 5 different colors. So we choose only one color, so 1 out of 5, so that will be equal to 20. So this is our expected frequency. Next one, suppose a person has 8 red, 5 green, 12 orange and 15 blue balls. Test the null hypothesis that the colors of the balls occur with equal frequency. Then what is the chi-square value you get? So it is given there are 4 different balls. So 8, 5, 12 and 15. So 4 different color balls. We have to find the chi-square value of the given problem. So calculation. So chi-square test, the expected frequency will be number of observations, that is 8 plus 5 plus 12 plus 15 divided by 4, so that is equal to 10. So chi-square formula, summation of O minus E whole thing square by E. So the observed values are 8, 5, 12, 15. Therefore O minus E whole thing square by E will be, so observed value 8 minus 10 whole thing square divided by 10, because divided by E here, plus 5 minus 10 whole thing square by 10 plus 12 minus 10 whole thing square by 10 plus 15 minus 10 whole thing square by 10. So that is equal to 5.8. So the answer is D. So thank you. We will see in the next session.